In this video, we will study Euler's theorem, which states that for a homogeneous function z equals fxy of degree n, how we can directly write the value of x dou z by dou x plus y dou z by dou y as this degree n times the function z. In short, just by knowing degree of homogeneous function n, we can directly write the value of x dou z by dou x plus y dou z by dou y as nz. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Euler theorem states that if z equals f small xy is a homogeneous function of degree n, then x dou z by dou x plus y dou z by dou y equals nz. In my last video on Euler's theorem part 1, we have discussed at length what is a homogeneous function and how to identify it. Z equals fx comma y is a homogeneous function. We will substitute capital X equals xt and capital Y equals yt so that f of capital XY will be t raised to n f of small xy. We will name this equation 1. Now we will differentiate left side with respect to t, which will be dou f by dou t equals dou f by dou x into dou x by dou t plus dou f by dou y into dou y by dou t, which will be dou f by dou x into dou x by dou t will be x because x is small xt plus dou f by dou y into dou y by dou t will be small y because capital Y is small yt. Now here if we put t equals 1, then capital X will be small x and capital Y small y. So this equation will become dou f by dou t equals x into dou f by dou small x plus y into dou f by dou small y. We name this 2. Next, we will differentiate right hand side of equation 1 again with respect to t, which will be dou f by dou t equals derivative of t raised to n will be n t raised to n minus 1 into f of small xy. Here also if we put t equals 1, dou f by dou t will be n into 1 raised to n minus 1 into f small xy, which will be n f xy, or dou f by dou t equals nz. We name this 3. Now left hand side of equation 2 and equation 3 is same, so we can equate their right hand sides. That gives expression of Euler's theorem x dou z by dou x plus y dou z by dou y equals nz. Let us verify Euler's theorem for function u equals f of x upon y. First we write u as f of capital X upon capital Y, and after that we replace x by small xt and y by small yt so that u becomes f capital X upon capital Y equals f small xt upon small yt. After cancelling this t, f capital X upon capital Y will be f of x upon y, which we can write as t raised to 0 f of small x upon small y. Since f capital X upon capital Y equals t raised to 0 f small x upon small y, means that this function is homogeneous with degree n equals this 0. Next, from u equals f of x upon y, we find x dou u by dou x will be x times derivative of u with respect to x will be 1 upon y, which is constant, and derivative of x with respect to x is 1. That will be x upon y. We name this 1. Next, we find y dou u by dou y. That will be y into. Now, partial derivative of u with respect to y will be x into derivative of 1 upon y with respect to y minus 1 upon y square. After cancelling y, we get minus x upon y. We name this 2. Now, from 1 and 2, we write x dou u by dou x plus y dou u by dou y equals from 1 x upon y, from 2 minus x upon y. Cancelling, we will get 0. We name this 3. Now we will apply Euler's theorem on u and write x dou u by dou x plus y dou u by dou y equals degree of homogeneous function n into u. But since degree is 0, this will be 0 into u, 0. We name this 4. Now, from 3 and 4, we find that Euler's theorem is verified. Remember, this should be u and not z. If u equals x upon y plus y upon z plus z upon x, then we have to show that x dou u by dou x plus y dou u by dou y plus z dou u by dou z equals 0. We have u equals f of capital X y z equals capital X upon capital Y plus y upon z plus z upon x. So f of xt, yt, zt will be xt upon yt plus yt upon zt plus zt upon xt. After cancelling t will be t raised to 0 f of xyz, which means that this given function is homogeneous function of degree n equals this 0. Now, by Euler's theorem equals degree of homogeneous equation n multiplied by u, which is 0 into u, 0. Hence, this is shown. In the next method, we will find x dou u by dou x, y dou u by dou y, z dou u by dou z separately, and then add them together. So first, x dou u by dou x will be differentiating partially this with respect to x. X into dou u by dou x of x upon y will be 1 upon y into 1 plus dou u by dou x of y upon z will be 0 plus dou u by dou x of z upon x will be z into minus 1 upon x square. This will be x upon y minus z upon x. On similar lines, y dou u by dou y will be y upon z minus x upon y, and z dou u by dou z will be z upon x minus y upon z. Now we will add them together. X dou u by dou x plus y dou u by dou y plus z dou u by dou z will be x upon y minus z upon x plus this y upon z minus x upon y plus this z upon x minus y upon z. This will be x upon y minus x upon y upon z minus y upon z, and z upon x minus z upon x will be 0. Hence, this is verified. If u equals xy f of y upon x, then we have to prove that x dou u by dou x plus y dou u by dou y equals 2u. F xy will be xy f of y upon x. After putting xt and yt, it will be f of yt upon xt. This will be t square xy. After cancelling this t, f of y upon x. Since f of capital XY equals t square f of small y upon x implies that a given function is homogeneous function with degree n equals 2. So, by Euler's theorem, this left hand side will be degree n times u, but degree n is 2, so this will be 2u as required here. Hence, this is proved. Pardon me, this should be f capital XY equals t square f of x comma y or t square u, where this 2 is the degree of homogeneous function. So let me erase this. If u is root xy upon root x plus root y, we have to find the value of x dou u by dou x plus y dou u by dou y. F capital XY will be f small xt yt, that will be square root xt yt upon square root xt plus square root yt, which is square root t square xy upon square root t into square root x plus square root t into square root x. So f capital XY will be t square root xy upon t raised to half into square root x plus square root y, which is t raised to half square root xy upon square root x plus square root y, which is t raised to half into u, which shows that u is a homogeneous function of degree n equals this half. So this value according to Euler's theorem will be nu, that is half times square root xy upon square root x plus square root y. So this is the required value. Let me correct, this is not root x but root y. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.